Well, hi, good morning, ladies and gentlemen. Welcome to the Oman Petroleum and Energy Show webinar on digital and project strategy of OZNA. The webinar will be presented by Mr. Nadim Wafin, Key Accounts Manager of OZNA. OZNA is an end-to-end solutions provider for oilfield surface infrastructure operating in Russia and represented by Dohat Al Khalij in Oman. In our session today, we will discuss challenges faced by oil and gas companies and solutions provided by OZNA, digital and product strategy, vision and applications of OZNA, hardware products developed by OZNA, followed by Q&A session. Over to you, Nadim. Thank you.
Okay, good morning, ladies and gentlemen. Thank you for joining our webinar that we are holding on Oman Expo platform. My name is Nadim. I'm invited speaker for this webinar. So I will present. I have only 20 slides to present to you, and after that I will be happy to answer your questions. Today, I will talk about the key challenges faced by the oil and gas companies. I will talk about the OZNA company and our partner. I'll give you our OZNA digital vision and strategy, the way we see how we can, package solutions in order to help oil and gas companies. I will talk about few products from our digital portfolio, and then we land on the ground. I'll talk about the hardware products. Okay, what is OZNA? OZNA was established in 1953 in Soviet Union to serve oil and gas industry, and it was simply manufacturing metering units. But today it grew considerably, and it has more than 1,000 employees, out of which almost half engineers, and out of which half, about 30%, are software engineers. So we have like four main divisions. It's a metering, fluid metering, fluid treatment, module units, and pumping. And on top of that, we have like product digital solutions. The next slide. In Russia, we are about we are holding a third of market share for metering units. We serve all major customers in Russia and GV, like Gazprom, Lukoil, Rosneft, Sakhalin Energy, ConocoPhillips, Total. Our headquarters is located in Ufa, and we have 9 regional offices. The reason because we want to be as close to the customer as possible. Now we feel strong enough, and we decided, okay, hey guys, we want to go to the international market, and we implement the same approach. We want to have a local partner which is close to the customer office because number of reasons, right? If you're close to a customer, your communication channel is very short. You can respond to queries very quickly. If you want to visit customer, you just go to the office, and most of the issues resolved in a much faster way. Plus, it's cheaper if you have office close to the customer. And how we did it, we also want to work with a partner who can we help with the technology export. And our partner in Oman is Dohat Al Khalij. There are a few key milestones. We first met this company in Oman Expo, and that's the reason we are holding this webinar on Oman Expo platforms, and we have a stand on Oman Expo with our partner in basically joining our business in Oman. So we met DAG guys in Oman Expo. We invited them to OZNA facility in Ufa. And next year, OZNA personnel went to Oman to get to know the local market and the Dohat Al Khalij facilities. And then we signed the agency agreement. Last year, now we completed accreditation in Oman, and now we're actively taking part in tenders in Oman. Now, let me go back to the original objective of this presentation. What are the problems and what are the solutions? So we split the problems faced by the customer on like obvious blocks. It's a reservoir management, well production management, water injection, and surface facilities. And from our view, we think that about 70% of the accumulated underperformance comes from all these blocks. But because we are the company who provides solutions from the wellhead to a custody point, I will focus on this area only. So why we talk about the digital? Well, digital oil field is basically the term that everyone in oil and gas uses these days. But was it true? How we see it? In OZNA, we see that digital instruments and tools helps you to have your asset to be at optimum level, 24 hours per day, 365 days per year. Effective fluid and field management. And as per our view, it stands on 3 blocks: data, algorithms, and human and machine intelligence. In order to have like true oil fields, every object in the oil field shall be connected to the platform. But here the question comes, what is data? The data consists of 3 items basically. It's data sufficiency, data quality, and data cost. And I highlighted in yellow, the data cost is very expensive if you want to have every object connected. But once you have all data, you clean up all the data, you need something to process the data, and this is algorithms. For algorithms, you have input and output, so the quality you have in, you got the quality outside, and the cost of algorithm, which is processing. So you need to have like IT software engineers, you need to have mathematicians, reservoir and production engineers to design the algorithm, test it, and run it, and it's very expensive. And the third block is human intelligence. Today we see that machine cannot replace human. Some of the expertise cannot be put in the machine brains. That's why we think it will be the combination of human expertise with machine assistance that provides together this optimum performance 24/7. Because, for example, the night shifts, the quality of decisions made during the night shifts are not the same. Hold on a second, something happened with my presentation. Okay, I think you can see it right now. So all these 3 blocks, data, algorithm, and human intelligence, is a foundation for the digital strategy. But the digital strategy is kind of virtual concept. So we packaged our digital strategy in a pyramid that represents our digital strategy and the products. And the beauty of that pyramid, that at every level and every section of the pyramid, OZNA has a separate solution that works separately and independently and is a building block. Once you add, like for example, from data gathering, you can go to the next level, mathematical algorithms, then next level to data interpretation, and the control tower, which basically allows you to control and operate your assets. On the sideline of the pyramid, you see the products. Basically, we have digital product like metering unit. We have OZNA digital flow meter and the custody metering units. So we have it in the hardware and software. And why we created? How would it work? What is the situation today? So the next slide. So do you know that in Russia, one well is under metering is only 3% of the time. Yes, it's only 3% of the time because of the well pad drilling. We have like 14 to 25 wells and 1 metering unit that cycles each and every well. So basically 97% of the time the well is monitored via the wellhead gauge or through the ESP data. Whenever there is a problems, despite of the high level of development of IT tools, every user generates his own data set to analyze the well performance if needed. For a well performance and intensification assessment is based on the expert opinion, and it takes time. You know that in data mining, it's about 80% of the time goes to the data quality and data cleanup. In most of the cases, if you want to know what's going on the well, you make a field visit because you want to see it by your own hands. And we thought, okay, how we can solve it? So we selected two areas. First of all, you want to know the truth about well. What is really going on? And the way you need to know it, so you have the all information on hand, you have all critical information, you have clean, verified information. And this comes to a second point that allows you to make very quick decisions, because your attention is focused on the very critical wells, for example, on the shutdown, the wells that underperforms. So you focus on the critical tasks and wells that affects your production. And now how it works in reality, because I said that we are focused on from the wellhead to the custody point, what problems do we see in the surface facility infrastructure? As a bottom line, we think that surface facility infrastructure is basically underloaded or loaded for only 50% of the time, which means you have the huge room for maneuver. For example, for the operational mode, you need to count the fluid time in separator, fluid phase state in separator, chemical treatment temperature controls. The pumps can give you the problems with the performance, right? Oh, what's going on? I just lost my presentation again. Okay. Then we have the unstable technology regime when we have different phases. And then we have, of course, equipment downtime. So basically, we are losing about 50% of the capacity for the surface facilities. And how we can fix it? This is a very good slide. I like this slide. So we have a target state when we want to have the high quality of treatment, which is green point, and high load of surface facilities. So what's today is going on, it's always a compromise. We either have high load but low quality of treatment, or high quality of treatment but very low load, which in today's environment, when we have like radical market changes for oil price and management focus on the OPEX, this is not acceptable. So our end game result is to move from this compromise area to, I call it North Star. We want to have high quality of treatment and high load factor at all times. And this is, I draw how we see this can work. First of all, today, you do this, if you look on this to the left, the decision point is time to time. So the first approach we see is to rapid decision to minimize the downtime. The next phase is to semi-automation, when you have a human machine assisted system that tells you, okay guys, you need to change this point and this point, and then you can improve your performance. And the next level, which is we call fully automation, when the system readjusts itself automatically based on the input parameters. And why do we think this can work and we have capabilities to do it? Well, because today we have these capabilities. We actually do it, but we call it today as a reengineering. We assist our customers to enhance surface facilities performance. We remove the bottlenecks, we upgrade them, we basically fit them to the current conditions. Another product that we have today, and it's on the run, we call it digital passport, where all documentation for the equipment is located in one place, and it helps either field service personnel or maintenance personnel or engineers from the remote monitoring center go exactly to the point and see where the problem is. So this is a ready product. And the next product, we call it digital flow meter, where I said we have a well monitoring and well surveillance at all times 24/7, because I said, remember I said that every well is about only 3% time under metering conditions, so 97% of the time we do it using digital tools. And combination of hardware, combination of digital passport and digital model gives you the equipment digital twin, which basically is a building block for the digital oil and digital oil field. Now let's change gears and see what we have in the ground. As today we have number of hardware products we are promoting in international market. The first one I want to talk about is a multi-port selector valve, which is used to direct the flow from the well to a metering unit and let other wells flow to go to the production pipeline. And this MSV is quite popular in Russia and becomes popular in Middle East. And we are designing one, and we expect to release one MSV as per ASME standards this year. And I ask you, please follow LinkedIn profile, because the next webinar we're going to run, it will be only for MSV. Next product I want to talk about is a compact size separation and metering unit. This unit is very compact. You can move it using light truck. You don't need external power. You use solar power to power it up. You can connect it to the OZNA remote engineering center, where our engineers will check the settings and adjust the operating mode, so you can operate it in an efficient way. And of course, the classic one, which is three-phase separator. A standard product, and we're actively promoting it in international markets. And the last slide, this is our business development and sales team. Oh, you can follow me on the LinkedIn, or you can find it in a LinkedIn profile. So I would like to now go to the, I see already questions, Q&A session right now. Okay, can I display it, or shall I read it? Okay, what is the percentage of error reduced by the digital passport? It's a good question. I think I would answer it this way. What type of errors we have, right? What we consider error? Well, the error is mishandling the equipment. Either it's mishandling the equipment operation or maintenance. So the original idea of the digital passport is to provide people with the right documentation and with the right tool to identify the component. So basically, people mishandling the equipment when they don't know either what is this equipment and how to handle it correctly. So the digital passport allows you to basically to scan the piece of hardware and move you to this manual for this component. So it gives you the right document for the right hardware. But in order to answer your question, I don't know how many, or what is the percentage of error. We believe it's quite high. The second question, shed more light on the functionality of the virtual flow meter. Okay, I can show the question list actually. Okay, you see my questions. Okay, shed more light on the functionality of the virtual flow meter and let us know the certainty achieved when compared with the well test separator. Very good question. The question number one, right? Okay, so let me go back to the basics. So the idea behind the digital flow meter is to have an eye on the well when it's not under metering, right? So our objective is to have 5% of, no, 90%, 95% of accuracy during the well flow digital flow metering. The actual results are within the range, but the question is how long your digital flow meter can hold this accuracy, and this is the biggest challenge. If the well condition is stable, then we can talk about months. If it's very stable, and we can talk about like maybe 5-6 months, even 9 months. I would say that today our target is to have 5% within like 3-4 weeks. And what it gives you, it's not basically replacing three-phase separator, but allowing you to optimize the wheel's three-phase separator utilization. So our target, I would say, is a business target when it makes sense. It should be like by 30 to 40%. Next question. In the compact size metering unit, how is the data transmitted to the office? It's through the GSM modem, through the cellular network, basically through the phone SIM card. I would say we can make either radio as well. It's basically a question of a local application. If you have like network coverage, we can connect to network. There's not there where we can use a radio. Let me see next question. For virtual meter, are you using learning model based on well completion, or is the model based on the test separator meter for oil, water, and gas legs? Good question. In Russia, because this product was developed in Russia and basically suits the Russian environment, 90% of the well production achieved using ESPs. So our digital flow meter is used model of the well completion profile. Of course, we use ESP design data. We use surface facilities data. We use three-phase separator data. We use VX data if it was applicable in the well. We use PVT analysis, and so basically we try to use data we have on hand. Based on test separator, yeah. How much, the next question is, how much cost is reduced by using multi-port selector valve? When we compare to this valve, right, structure, it's about 30 to 40% when compared to the classical tubing layout. I think I don't see any. Let me see if I missed any questions on the top. The next question is, the virtual flow meter model sits on edge device or in cloud in Russia? Classical question. We have two solutions, right? We have OZNA cloud solution, and there is an option for this mode, for this engine to be based on the customer server. Basically, it's a packaging. It's a box application. Yes, it's two options. It depends on the customer. Like big customers, large customers, they have their own cloud, so we can transfer engine to the cloud or have a local server. Yeah, let's see if you have more questions. It was very good questions actually. May I ask you if you see what problems do you see with your surface facilities infrastructure? Do you think it's the way we present it? Does it make sense for you?
Well, I believe there are no more further questions have been asked. Thank you, Nadim, for sharing valuable insights. And thank you, everybody, for attending today's webinar. Thank you. Have a nice day.